In this video, we're going to talk about working with Unix. Now, nearly all numbers that we work with in daily life represent the amount of something. For example, the number 3 might represent 3 apples, $3, or 3 hours. The words that describe what we're measuring or counting, such as the apples, dollars, or hours, are called Unix, and they're associated with the number. When we're working with unit analysis, we need to be comfortable with fractions. So before we actually jump into unit analysis, working with Unix, we are going to do a brief review of fractions. A fraction can be represented in 3 basic ways. You have a fraction with a fraction bar. So the 1/2 represents a division problem. It's 1 divided by 2. That fraction bar represents division. The number in the top is called the numerator, and the number in the bottom is called the denominator. We can also represent fractions as decimals and then as percentages. Percent means out of 100. In order to move from a number to a percent, which means either a fraction or a decimal to a percent, we're going to multiply by 100. If I want to change a percent to a number, meaning a percent to a decimal or a fraction, we're going to divide by 100. So if I want to take 1/2 and change it into a decimal, we're not changing it into a percent, so I'm literally just going to do division, and I'm going to put 1/2 in my calculator, 1 divided by 2, and it's going to come up 0.5. But if I want to go ahead and change that decimal to a percent, I'm going to change this number to a percent. I want to multiply by 100. So if I put 0.5 and multiply by 100 in my calculator, I get 50, and then I have to, because it's percent, I'm going to add in the percent symbol. Now going in the other direction, if I have a decimal and I want to write it as a fraction, I want to take the number of digits that I have in my decimal and write it over in my denominator, a 1 with that many zeros. So if I have 3 digits, I want to do a 1 with 3 zeros in my denominator. So this is going to be 314 over 1,000. And then I can reduce it. I can divide everything by 2 because 2 goes into 314 and into 1,000. And I get 157 over 500. I can always double check on my calculator to make sure I reduce the fraction correctly by putting in 0.314. So by default, the calculator is going to use decimals, but then I can tell it to change the 0.314 into a fraction, and by default, again, the calculator will give it to me in reduced form. So to change 0.314 into a fraction, I'm going to hit the math button right here. And then the very first option, number 1, says fraction. So I'm going to hit enter. So this is telling me I'm going to take 0.314 and change it to a fraction. I'm going to hit enter, and it's going to tell me 157 over 500. Now I want to write this as a percent. When I want to write a number, whether it's a decimal or a fraction, into a percent, I need to multiply by 100. So I can take my 157 divided by 500, or I can take the 0.314. Either way, it's going to give me the same answer, and I'm going to multiply by 100. So times 100. That's going to give me 31.4. And because it's a percent, I want to make sure I put that percent symbol in there. Okay, now going backwards, for the next example, I have 22.3%, and I want to change that to a decimal and a fraction. So I want to take 22.3 and I want to divide by 100. So in my calculator, I put 22.3 divided by 100, and I'm going to get 0.223. Now to change it into a fraction, since I have 3 digits after my decimal place to the right, I want to do 233 over 1,000, right? A 1 with 3 zeros because there's 3 places. And then I want to reduce it. And actually this one doesn't reduce. There isn't a number that goes into 233 and 1,000. So now I can double check it if I'd like on my calculator. I can do 22.3, and we divided by 100 because we're going from percent into decimal and fraction form. So I'm going to divide by 100. The calculator will give me the decimal value, and then I can also ask it to give me the fraction value in reduced form by hitting math, fraction, and then enter. And it's going to give me 223 over 1,000. Oops, I just realized I put 233. Okay, so the next example, we have 5/4, and I want to change that to a decimal and a percent. So to change 5/4 into a decimal, remember the fraction bar means divide. So I'm going to take 5 divided by 4. That's my decimal value, 1.25. And then if I want to put it in percent form, if I want to take a number, whether it's a fraction or a decimal, and put it in percent form, I need to multiply by 100. So when I take 1.25 and multiply by 100, I get 125, and I have to remember to put percent there because now we're doing percents. Okay, the next example, 7 4/11%. So it looks like it's in fraction form, but because it's got that percent sign, it's really in percent form. So I want to change that 7 4/11 to a decimal. And when we want to change from percent to a number, whether it's decimal or fraction, I need to divide by 100. So in my calculator, I'm going to put in parentheses, since 7 4/11 really means 7 plus 4/11. You got your whole number plus your fraction. So I'm going to do 7 plus 4/11. There's my 7 4/11. And now I want to take that number and divide by 100 to get it out of percent form and put it in decimal form. So divide by 100. And I get 0.0736, and the 36 is repeating, so we're going to put the bar over it. Okay, now to change that into a fraction, I just go ahead now and tell the calculator, I want to go to math and to fraction and tell the calculator to put that back in fraction form. So that's 81 over 1100. Okay, the next example is 6.2 as a decimal. We want to put it in fraction form and in percent form. So I can take 6.2 and tell the calculator to change it to fraction form. That gives me 31 over 5. And then to put it in percent form, if we're in number form and we want to go to percent form, we want to multiply by 100. So I'm going to take 6.2 or 31 divided by 5, either one, you'll get the same answer, and I'm going to multiply by 100. That's going to give me 620%. Remember that percent sign. Now we have a fraction that we want to put in decimal form. So I'm going to take the 7 over 9, and I'm going to use that fraction bar as division. And I'm going to do 7 divided by 9. And I'm going to get 0.77 repeating. And we can write that as 0.7 with the bar over it. Now to put that in percent form, whether we're in fraction or decimal form, and we want to change it to percent form, we want to multiply by 100. So now I'm going to times by 100. And I get 77.7 with the bar over it repeating. If we want to round it to one decimal place, we can just write 77.8%. Since the 7 is higher than 5, we want to bump up the first 7 in the tenths place to an 8. Okay, the last example to review fractions, decimals, and percents. I have a percent, and it looks like it's in decimal form because I have the 0.003 there, but the percent in front of it means it's not in decimal form. It's a percent. So to go from a percent to a number, I have to divide by 100. So I'm going to put in the calculator 0.003 and divide by 100, and I'm going to get 0.00003. So a really, really small number. Since I have 1, 2, 3, 4, 5 decimal places, I'm going to write 3 over a 1 with 5 zeros. 1, 2, 3, 4, 5. Now, with division involving 0, just a quick review. If I have a number divided by 0, and we can write it as a fraction like this. Let's just make up an example, 5 over 0. This is what's called undefined. And the reason we can say that is recall that if I say 8 divided by 4 is 2, remember that fraction bar is just a division sign, another way to write division. So if I take 8 divided by 4, it's 2. Now I can work backwards to double check it. It should work that 2 times 4 should give me 8. So if I now go back to this, I'm asking you what number times 0 would give me 5. That's impossible. There is no number times 0 that would give me 5. And that's why this is undefined. And it doesn't matter what number is on the top. It could be 4, it could be 1,000,000, it could be -7. It doesn't matter what's on the top. When 0 is in the denominator, you're dividing by 0 and it's undefined. Now, if I have the 0 on top, if I have 0 divided by some number, doesn't matter what it is, this is just equal to 0. And you can double check to convince yourself that it's true, because if I go back and check it, this is saying 0 times 5 is equal to 0, and it works. So when the number on top is 0, the whole fraction is equal to 0. And when the number on the bottom is 0, the fraction is undefined. Okay, now we're going to practice doing arithmetic with operations. And I'm going to show you how we can do this on the calculator to make things a little bit easier and go more smoothly in class. So I show you where the fraction button is on your calculator. So what we're going to do is we're going to do all these calculations, and then we're going to hit enter on the calculator, and the calculator will give us a decimal value by default. But then we're going to go back to the fraction button and tell the calculator to change our answer back into a fraction. So for the first example here, 2/3 plus 4/5. Now, whenever we enter a fraction in on the calculator, we need to put parentheses around it. So I'm going to put in the calculator 2 divided by 3. So there's my first fraction, plus 4 divided by 5. So in parentheses, here's my parentheses right here, parentheses, 2 divided by 3, close parentheses, plus 4 divided by 5, close parentheses. I'm going to hit enter, and by default, it's going to give me a decimal value. Now, what I want to do is I want to change it back to a fraction so I can write down my answer in fraction form. So I'm going to hit the math button, and I'm going to hit option 1 that says change it back to a fraction. And the answer is going to be 22 over 15. Okay, for the next one, I'm going to put in parentheses everywhere I see a fraction, I'm going to put parentheses around it. Now, I already have parentheses in the problem. So here are the parentheses that are already in the problem. And then I need to put parentheses around the 4 3/4. Remember, a mixed number means the whole number plus the fraction part. So in parentheses, I'm going to put 4 plus 3/4. And then I'm going to subtract 6 divided by 11 in parentheses. And then these are the parentheses that were already in the problem. These were the parentheses that we added in. And then I'm going to square it. So this is how we have to put it in on the calculator. So parentheses, and then another parentheses. 4 plus 3 divided by 4, close parentheses, minus 6 divided by 11, close parentheses, and then my second set of parentheses that closes the whole thing, and then I'm going to square it. Now, to raise something to a power, you can hit this little button that looks like an arrow right above your division sign. I'm going to hit that and then hit squared. So my answer in decimal form is 17.678, and that's rounded because I stopped at 8. Okay, that's not the exact value. That's a rounded decimal. But then if I want to change it to exact value and put it back into fraction form, I'm going to hit math, go to fraction, and hit enter. And so that is 34225 all over 1936. That's a big messy fraction. Okay, now the last example, I put this one in your notes because I wanted to emphasize how important it is that when you have a fraction within a fraction, so in the numerator I have fractions, in the denominator I have fractions of the big fraction. So I have different fraction bars here. That's called a complex fraction. And so whenever you're doing fractions, you want to make sure whenever you're working with complex fractions, you want to make sure that you put whatever the arithmetic is on the top in parentheses. Because the top, you take the top divided by the bottom. So that big division bar, this one right here, I call that the big division. That's a whole nother operation. So I'm going to put in parentheses for the numerator 4/3. That goes in parentheses. This goes with the numerator, and this goes with the fraction 4/3. Plus, then I do my fraction of 1/5, 1 1/5. So I have 1 plus 1/5. And then I close that. So these here, that says all of that is in the numerator. Then the blue parentheses represent the parentheses that go around the fractions. So we're going to do the same thing for the denominator. I have parentheses for the denominator, and then I have parentheses for each individual fraction in the denominator. So this is going to be 2/3 minus 1/8. So this is how I'm going to put it in on the calculator. So I'm going to do parentheses for the numerator, and then parentheses for the 4/3, 4 divided by 3. Close parentheses for the 4/3. Plus, then open parentheses for the 1 1/5. 1 plus 1 divided by 5. Close parentheses for the 1 1/5. And then close parentheses for the numerator. Then I'm going to do the division bar. And then I'm going to open parentheses for the denominator, and then open parentheses for the 2/3, minus 1/8. and then close parentheses for the denominator. As you can see, there's lots of parentheses. The benefit to doing it on the calculator is you don't have to worry about finding common denominators, and it saves you that arithmetic. But when you have a complicated expression like this, you have to make sure you put your parentheses in the right places, or you're not going to get the correct answer. So until you get comfortable with this, I would definitely make sure, if you have something like this that you have to work out, that you put all your parentheses and you write it out by hand first, and then you copy it into the calculator. Okay, so there's our decimal value for that expression, 4.67, and then it keeps going on, okay? And then we're going to change it back to a fraction to get exact value and not a rounded decimal. And it's 304 over 65. Okay, so now that we did a review of fractions, a very brief review of fractions, we can now get into the unit analysis part of this section. So just to recap what we talked about at the beginning of the video, we talked about Unix being a quantity that describes what the quantity is measuring or counting, like 3 apples or 3 hours. The apples and the hours are the Unix because it describes what the 3 represents, okay? And then unit analysis is the process of working with the Unix to help solve problems. Okay, now we're going to add one more term to our notes. It's called a conversion factor. And a conversion factor is a statement of equality that is used to convert between Unix. Okay, so, and it's typically shown as a fraction. Okay, so for example, I know that there are 12 inches and 1 foot. So a conversion factor, an example that I can use to convert inches to feet or feet to inches, I can use 12 inches over 1 foot, or I can use 1 foot over 12 inches. Because 12 inches is equal to 1 foot, and because 1 foot is equal to 12 inches, and the top and the bottom are equivalent, that factor, which is set up like a fraction, is actually equivalent to 1. So when I go through and I start multiplying things in our problems by our conversion factor, all the conversion factors we have should be equivalent to 1. You're not changing the value of whatever it is that you're trying to convert. You're just changing the Unix and not the value. So any fraction that is equivalent to 1, where you have different Unix on the top and the bottom, is considered a conversion factor. So in the first example, I want to change 7 yards to inches. And we're going to identify the conversion factors. So I know a couple things. I know that there are 3 feet and 1 yard. And I also know that there are 12 inches and 1 foot. Now I can flip those upside down. I can put 1 yard on top and 3 feet on the bottom, and I can put 1 foot on top and 12 inches on the bottom. It doesn't matter what's on the top and the bottom because it's still equivalent to 1. When we are trying to convert Unix, that's when the order matters, what you put on the top and the bottom, so that you cancel the Unix out and keep the Unix that you want. So we always start with what we're trying to convert. I'm trying to convert 7 yards into inches. So I'm going to write down 7 yards. And I'm going to put it over 1 because this is going to be like a chain of multiplication of factors that are fractions. So if you have just a whole number, it makes it a lot easier to put it over 1 so things line up. So I have 7 yards. There's my first factor. This isn't a conversion factor because the top and the bottom are not equivalent. Okay, now I want to change yards to feet, and then I can change feet to inches because our goal is to get to inches. Okay, because I want to get rid of yards, I want to put yards in the bottom. So I'm going to put 1 yard is equal to 3 feet. So there's my conversion factor, one of them. So this would change it, if I multiply this out, this would change the yards to feet. But we want to go all the way to inches, so then I'm going to do it again. I'm going to add in another conversion factor, and I'm going to take, and I'm going to put feet on the bottom. So 1 foot is equal to 12 inches. And that way I can cross off all the units that are the same. So I have yards can get crossed off, and feet can get crossed off. So now I'm left with inches. Everything else got crossed off. So when I multiply this out on my calculator, my final answer is going to be in inches. So let's go ahead and do that. Since we just reviewed how to multiply fractions and how to add fractions and do all that stuff on the calculator, this should be a breeze now. So in parentheses, I'm going to put 7 divided by 1 times, and then and my next fraction is 3 divided by 1 times, and then my next fraction is 12 divided by 1. So my answer is 252 inches. My conversion factors that I used was this and this. This was my other conversion factor. What's on the top and what's on the bottom are equivalent, so this is equal to 1. Just if I wrote the square root of 16 over 4. The square root of 16 is 4, so that's 4 over 4, it's 1. It doesn't look the same, but it is the same. And when we have the same on the top and the bottom of a fraction, it's like multiplying by 1. Okay, so in the next example, we're going to change 94 days, and I want to end up with seconds. So I'm going to start with 94 days, and I'm going to put that over 1 so my fractions line up and I can pay attention to what I'm doing here. Okay, so I want to go to seconds. So in my mind, I don't know offhand how many seconds are in a day directly, but I can do a chain of conversions. I know that 1 day is 24 hours. This is one conversion factor. I'll abbreviate it CF. But we're not done yet because we need to convert it to seconds. Right now, I've only gotten rid of the days, and I'm left with hours as of right now. So I have to do another conversion factor. Since I want to get rid of hours now, I put 1 hour is 60 minutes. So now I can get rid of hours. Here's my second conversion factor. I'm not done because this would change it into minutes, and we want seconds. So I still need one more. I want to put minutes in the denominator, so 1 minute is 60 seconds. So now I've just gotten rid of the minutes. So now I'm left with seconds. That's my only unit that's left. I got rid of everything else using my chain of conversion factors. Here's my last conversion factor. So now I just have to put all of this in on my calculator. It's a string of multiplication of fractions. So in parentheses, I'm going to do 94 divided by 1 times 24 divided by 1 times 60 divided by 1 times, and then again for the seconds, 60 divided by 1. And that is a lot of seconds. So 94 days is equivalent to 8121600 seconds. Okay, here I have taken a chart that I found And this will give you some keywords, and so you'll know what to do when you see these keywords. Okay, per means division. And so when you see, here's the example here, when you see miles per hour, that means the unit miles per hour means you're going to take whatever the miles are and you're going to divide by the number of hours. So for example, if I was going 100 miles for every 2 hours on the highway, and I said 100 per 2 hours, 100 miles per 2 hours, I would take 100 divided by 2, and that's 50. So I would be going 50 miles per hour. The word of, or if you see a hyphen, means multiplication. So if you see kilowatt dot or dash hours, that means you take the kilowatts and you multiply by the hours. If you see the word square, that means you're raising it to the second power. Or you could write it as whatever the unit is multiplied by itself. So for example, you could take feet times feet. That's one way to say feet squared. Or you can write it as feet with a little 2 up there as an exponent 2. And cube or cubic is the same idea, but you're dealing with, rather than area with squares, you're dealing with volumes that are cubes because you have the unit multiplied 3 times. Feet by feet by feet, or you can write it as feet cubed, and that would give you a volume, where this would give you an area. Okay. So the next example, it says, for part A, it says, what is the total distance traveled when you run 7 laps around a 400-meter track? So this tells you what your conversion factor is, because for each lap, it's 400 meters, right? If the track is 400 meters, that means every time you go around it, you do 400 meters. So I'm going to write down my conversion factor. I'll abbreviate it CF. 400 meters is equal to 1 lap. And remember, I can flip it if I need to. I can put 1 lap on top and 400 meters on the bottom if I need to, depending on what I'm trying to convert. This is what I'm trying to convert. It says to convert 7 laps into the distance into meters, okay? So I'm starting with 7 laps. That's what I'm trying to convert. I'm going to put that over 1 so I can line it up and do my chain of factors. I want to get rid of laps, and I want to end up with meters. So since I want to get rid of laps, the laps is going to go on the bottom since I want to cancel these out. So 1 lap is equal to 400 meters. So now I can get rid of lap and lap. And so now on my calculator, all I have to do is put in my calculator 7 over 1 times 400 over 1. So in parentheses, I'm going to put 7 divided by 1, and then times 400 divided by 1. And that's going to give me 2,800 meters. Okay, the next example says, how many crates do you need to hold 2,000 apples if each crate holds 40 apples? So they're giving you the conversion factor. 1 crate is equivalent to 40 apples. This is my conversion factor. We want to convert 2,000 apples and figure out how many crates they are. So I'm going to start with 2,000 apples. Put that over 1. And since I want to get rid of apples and change it to how many crates we're going to have, I'm going to put apples on the bottom. So 40 apples is equal to 1 crate. So now I can cross off my apples. And then on my calculator, I'm going to put in parentheses 2,000 divided by 1 times, and then in parentheses 1 divided by 40. When I do that, I get that it's 50 crates. Okay, part C says, the length of a Kentucky Derby horse race is 10 furlongs. How long is the race in miles? And then it tells you your conversion factor. 1 furlong is 1/8 of a mile. So I have 1 furlong is 1/8 of a mile. This is my conversion factor. Since we want to convert 10 furlongs into how many miles, because the question is asking for miles, I'm going to start with 10 furlongs. Put that over 1. And then I want to do my conversion factor. Since I want to get rid of the furlongs are going to go on the bottom. So I have 1 furlong. And then on top, I'm going to put 1/8 of a mile. Okay, so in my calculator, I'm going to put 10 over 1 in parentheses times, and then in parentheses, I'm going to do 1/8 over 1. That's going to get rid of my furlongs, and when I multiply that out on my calculator, I'm going to get that it's 1.25 miles. So 10 furlongs is equivalent to 1.25 miles. Okay, in the next set of examples, we're going to talk about how we deal with conversions when we have units that are raised to a power. Like if I have feet squared or yards cubed or something like that. Okay, so I have one, for the first example, it says change 1 square yard into square feet. So I want to take 1 yard squared over 1, and I want to change that to feet squared. The problem is that I know that there are 3 feet to 1 yard. I want to make sure the yard goes on the bottom so that I can cancel it with the yards on the top. But the problem is I can't cancel the Unix unless they're exactly the same. If you notice, this is yard squared and this is just yard. So I have to somehow figure out a way to make that yard squared. I can do anything I want as long as I do it to both the top and the bottom, right? This whole conversion factor is equivalent to 1. And when I take 1 and square it, it's still 1. So I can square this conversion factor. So I'm going to square this. It's still equivalent to 1. So now what's going to happen, I'm going to copy over the 1 yard squared over 1. But now I have 3 feet and I'm squaring it. I have to square everything that's inside those parentheses. So I take 3 squared, which is 9. Feet squared, which is feet squared. And then on the bottom, I have 1 squared, which is 1. And then yard squared, which is yard squared. Now I can cross off the yard squared. So on my calculator, I'm going to take 1 divided by 1 in parentheses times 9 over 1 in parentheses. And I'm going to be left with feet squared, which is what we wanted. So I have 1 yard squared is equal to 9 feet squared. When we're squaring length, remember, that's area, right? If I have feet here, and I multiply them, that gives me area. When I cube it, let's see if I can do this and make it look nice. That's adding another dimension. I have this dimension, and now I have the depth. So when you have something that's cubed and its length and you're cubing it, that's going to give you volume. This actually, that's a typo. Let's change that to volume. Okay, so the next example says, how many cubic yards of soil are needed to fill a planter that is 20 feet by 3 feet by 4 feet? And I need to change this to cubic yards. So if I take 20 feet by 3 feet by 4 feet, when I multiply that all together, I'm going to get 240 feet cubed. Right? The 20 times the 3 times the 4 gives me 240, and the feet times feet times feet gives me feet cubed. So now I need to take the 240 feet cubed and change it to cubic yards. So I have 240 feet cubed over 1. And since I know that there are 3 feet and 1 yard, I'm going to write that as my conversion factor. And because that conversion factor is equivalent to 1, I can cube it, right? Because 1 cubed, that's 1 times 1 times 1, which is still 1. So I'm going to cube all that. So this is the same thing as saying 240 feet cubed over 1 times 1 cubed is 1, yards cubed is yards cubed. Then on the bottom, I have 3 cubed, which is 27, right? 3 times 3 times 3, and then feet cubed. Now I can cancel out my feet cubes, and I can finish the problem. So on the calculator, I'm going to put 240 over 1 in parentheses, divided by 1. And then I'm going to put times, and then in parentheses, I'm going to do 1 divided by 27 in parentheses. And my final answer is going to be 8.89 yards cubed. Okay, for the next 2 examples, I'm going to let you try those yourself. But I am going to tell you what the answer is so you can check your answer. Okay, for this example here about the carpeting a room, you want to figure out how many square yards of carpet you need. The answer is 13.33 yards squared. In this second example, it says you're preparing a vegetable garden, and it gives you the volume. It gives you the 3 dimensions, 40 feet long, 16 feet wide, and then 1 foot deep. And you need to figure out the cubic yards of the amount of soil that you need. So you need to figure out the cubic yards of that vegetable garden. When you do that, you should get 23.7 yards cubed. So pause the video and try to do those yourself and see if you can get those answers. Okay, the next thing I want to talk to you about in this section is called the metric system. And we are going to be converting back and forth from the metric system to our US system. And in order to do that, we need to be familiar with powers of 10. So I want to quickly review with you what it means to be a power of 10 and and how you can put it in on your calculator. 10 to the third, when you take 10 and you raise it to some number, whatever that number is, will tell you how many zeros you have. So this means 10 to the third is going to be 1,000. It's going to be a 1 with 3 zeros. Now, if you see a negative in the exponent, that means you're still going to have 3 zeros. The negative tells me that I'm going to flip it upside down and take the reciprocal. Right now, even though we don't always write it in there, it's 10 to the negative 3 over 1. So if I want to get rid of that negative exponent, I'm going to flip it upside down. And that's going to give me 1 over 1,000, because 10 to the third is 1,000. So when you have negative exponents with powers of 10, it's going to be a really small number. So for example, this one is going to be 1 over because it's a negative exponent, you're going to flip it upside down, and it's going to be a 1 with 8 zeros. 1, 2, 3, 4, 6, 7, 8. So a really small number. Okay, 10 to the 8th is going to be a really big number because I'm not flipping that one. It has a positive exponent, so it's just 1 with 8 zeros. Whoops. So the negative exponent just means to take the reciprocal and flip it upside down. Okay, when you need to do operations with powers of 10, you're just going to put it in the calculator using your exponent symbol on the calculator. So to take 10 to the 5th times 10 to the 3rd, I'm going to write 10, and then to raise it to the 5th power, I use this little arrow to the 5th, times, and then I'm going to do 10, raise it to the 3rd, and that's going to be 1 with 8 zeros. Okay, for this one here, it's division, so I'm going to take 10 and raise it to the 5th power. And then I'm going to divide by 10 and raise it to the 3rd power. That's going to give me 100. When you have negative exponents and you want to put it in on the calculator, what you want to do is make sure that you put parentheses around the negative and the 5. For example, when we're looking at the next example here, I'm going to put 10 to the power of, and then this will be your negative button. Don't use the minus, so it will give you an error message. Use the negative button down here next to your enter. So negative 5, close parentheses. That's telling the calculator that you want to take negative 5 as your exponent, not just the negative, because it might give you an error message. You're telling it to take both of those pieces, the negative and the 5. Then I'm going to multiply it by 10 to the 3rd. That would give me the answer to the inside part of the parentheses, but then whatever is on the inside, then I want to take that and raise it to the 3rd power because of this. So I'm going to take my answer 0.01. That's equivalent to what's inside here. And then I'm raising it to the 3rd power. So I'm going to take my answer, hit the little caret button, raise it to the 3rd power, and I get 0.000001, 2, 3, 4, 5. There we go. Okay, the 1e to the negative 6, if you haven't seen that notation before, that means just take 1, here's my decimal place, and move it over 6 places to the left. And then I count over 6 places, which gives me the 5 zeros. Okay, last example. Remember, when you're dealing with fractions, you want to make sure you put parentheses around the numerator and parentheses around the denominator. So I'm going to put parentheses, and then I'm going to do 10 to the power of negative 5 divided by 10 to the 3rd. Close my parentheses for the whole numerator. Then I'm going to divide by 10 squared. That's going to give me 1e negative 10, which means 1, here's my decimal place 1, and I'm going to move it over 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Okay, so now that we have a review of powers of 10 and what it means, let's start talking about the metric system. Now, the metric system has what I like to call 4 bases. We have for length, we use meters, okay, and it's abbreviated M. Kilogram is used a lot, but I wouldn't call that the base for mass or weight. We're going to use grams. Grams for mass. And then for time, we use seconds. That we're familiar with because we use that with our US system. And then for volume, we use liters. And then what happens is whatever unit you're talking about, whether it's liters or seconds or meters or grams, what you want to do is to figure out how small or big that is. We use powers of 10. And then each power of 10 that we use has a prefix for it. So if I say I have a decimeter, this is my base and this is my prefix. Okay, deci is 10 to the negative 1, which means 1/10 of a meter. So we know it's going to be smaller than a meter. Okay, so we use these powers to be able to compare it to the base and come up with our conversion factors. Okay, so let's go through a couple examples to make sure we got this straight. So the problem says convert 2759 centimeters, and we want to convert it to meters. Our base is meters. We're talking about length. We're starting with 2759 centimeters. I want to change this to meters. Since I want to get rid of centimeters, I want to put centimeters on the bottom. So I'm going to say 1 centimeter is equal to so many meters. And this is where our chart comes in our powers of 10. To figure out how many centimeters are in meters, because meters are our base, centi is our prefix. So I look here. Let me erase this so that it doesn't get in the way. Okay, centi right here is our prefix. And 1 centimeter is equal to 10 to the negative 2 meters. So then I put that in on my calculator. I'm going to put 2759 over 1 in parentheses times 10 to the negative 2 over 1 in parentheses. And when we work that out, we get 27.59 meters. Okay, so this is our conversion factor. 1 centimeter is equal to 10 to the negative 2 meters, and we got that off of our chart. And the base is meters because we're talking about length. Now here we're talking about liters, which is volume. So my base is going to be liters. We want to change 20 kiloliters to milliliters. So we're going to start with 20 kiloliters. And I want to change this to milliliters. So if I look for kilo, kilo is my prefix. Kilo is right here. So kilo is going to go in the bottom because I want to get rid of kiloliters. So I'm going to say 1 kiloliter is equal to 10 to the third liters. That's my base. So it's going to be 10 to the third liters. But we're not done because it asked us to change to milliliters. So now I got to change liters to milliliters. So now I've got to change liters to milliliters. Now if I find my prefix, milliliters, in my chart, that's right here, milli, 1 milliliter is equal to 10 to the negative 3 liter, right? Because liters are my base. And this, let me kind of emphasize this, okay? This is what my base is equal to. So if I have 1 decimeter, that's equal to 10 to the negative 1 meters. So this represents what it's equivalent to for my base. Okay, so now I've got it set up and I just have to go through and put this in on my calculator. So now I have 2 conversion factors. This one here and this one here. Okay, so when I put that in all my calculator, so in parentheses I'm going to put 20 over 1 times, then in another parentheses I'm going to put 10 to the third over 1, then in another parentheses I'm going to put 1 over 10 to the third and multiply all that together, and my final answer should be 20 million milliliters. Okay, last example for this page. It says how many nanoseconds are in a microsecond? So seconds are the base. We're talking about time. So the base is seconds. The prefixes that we're dealing with here are nanos and micros. Okay. So we need to figure it out in nanoseconds, and they're giving us 1 microsecond. How many nanoseconds, that's what we're trying to find, is in 1 microsecond. So I'm setting up 1 microsecond. Okay, so second is the unit. Okay, microsecond, if I come up here and I look for micro, 1 microsecond is equal to 10 to the negative 6 seconds. So 1 microsecond is equal to 10 to the negative 6 seconds. There's my first conversion factor. Now I'm going to convert seconds into nanoseconds. So if I come up here and look at nano, 1 nanosecond is equal to 10 to the negative 9 seconds. So 1 nanosecond is 10 to the negative 9 seconds. So I'm going to put that into my calculator. In parentheses, I'm going to put 1 over 1 in parentheses times 10 to the negative 6 over 1 in parentheses times 1 over 10 to the negative 9 in parentheses. And when I do that, I get 0.001 microseconds. Now this is the conversion chart that you want to use when you're going back and forth between the two systems. We have the metric system, which we just talked about, where there's a base, and then you use prefixes to determine how big or how small it is. And then we have in the US, inches, feet, yards, miles, etc. Okay, so the first example says the marathon running race is about 26.2 miles. So this is using our US system, a unit from our US system. And it says, how far is this in kilometers? This is from the metric system. So we're going from one system to another system. So we're going to start off with what we know, 26.2 miles. And I'm going to look to see if anywhere on my conversion chart here, if I have anything that goes from miles to kilometers. If not, then I might have to put in a chain of conversion factors to get from one to the other to the next, to get wherever we're trying to go. Okay, so if I look here, it looks like I have 1 kilometer is equal to 0.6214 miles, or I could also use 1 mile is equal to 1.6093 kilometers. Either way, whichever one we use, we're still going to get the same answer. It doesn't matter which one you use. Okay, I want to go from miles to kilometers, so I want to make sure the miles is on the bottom. So let's say I use this one here. So I'm going to use 1 kilometer is equal to 0.6214 miles. So now I can cross off my miles and I'm left with kilometers, which is what we're trying to get. So in my calculator, I'm going to put 26.2 over 1 in parentheses times 1 over 0.6214. And when we do that, we get 42.16 kilometers. Okay, how many square kilometers are in 1 square mile? So it's the same idea of what we just did, but now we're squaring them. So I have to square my conversion factor. So I have 1 square mile I'll use the same conversion factor as I used up above. I have 1 kilometer is equal to 0.6214 miles. But because I want my miles to be squared, I'm going to square this whole thing. So in my calculator, I'm going to put 1 over 1 in parentheses times, and then I'm going to put 1 over 0.6214 squared. And when I square that and I multiply it by the 1 over 1, I'm going to get 0.386 miles. And that's going to be squared. Okay, the next topic I want to talk to you guys about is temperature units. So we have 3 different systems. We have Fahrenheit, Celsius, and Kelvin. And here's a picture that I got that kind of shows you where the boiling point is and where the freezing point is, so that you have an idea how to compare the 3 systems. Okay, so we have formulas to be able to go back and forth and change from Fahrenheit to Celsius and from Kelvin to Fahrenheit, etc. And these are the formulas that we're going to use up here. Okay, so in our example, it says the average human body temperature is 98.6 Fahrenheit. What is it in Celsius and Kelvin? So what we want to do is we want to use the formulas in the box to change Fahrenheit to Celsius and then change Fahrenheit to Kelvin. So if I want to change Fahrenheit to Celsius first, that's this formula right here. I'm going to take Celsius is equal to my Fahrenheit minus 32 over 1.8. The Fahrenheit that was given to us is 98.6 minus 32 over 1.8. Okay, when I put that in on my calculator, I'm going to get 37 degrees Celsius. And remember, this first one we were changing to Celsius, so we have to remember to label it as Celsius. Now I want to take and change Fahrenheit to Kelvin. The only formulas it looks like we have is from Celsius to Kelvin and Kelvin to Celsius. And we have what the Celsius is. So let's take the Celsius and change it to Kelvin. So we'll use this one here. We're going to say Kelvin is equal to the Celsius plus 273.15. So I'm going to take 37 degrees Celsius and add it to 273.15, and I'm going to get, when I put that in on my calculator, 310.15 Kelvin. So you want to use these formulas here to change back and forth between the different temperature systems. And the last part of this lesson, we're going to talk about currency conversions. This is the table we're going to use. And we have two options. They give us two columns. We have dollars per foreign money and foreign per dollar. So what this means, if I look at the first column here where it says dollars per foreign money, that means, for example, if I look at British pounds, that means I have, for every British pound, I have 1.624 US dollars. Now, if I look at this column, that means foreign per dollar. So that means for every dollar that I have for US dollars, I have 0.6158 British pounds. So they're giving it to us from two different perspectives. It doesn't matter which column we use as long as we label which one is dollars and which one is foreign money correctly. So the first example says, at a French department store, the price of a pair of jeans is 45 euros. What is the price in US dollars? So this is what we're trying to change into US dollars. So this is what we're going to start with. Now I have to change euros to US dollars. So I want to use either this conversion or this conversion factor. Doesn't matter which one. I'm going to stick with the 1.320. I'm going to use the first column. So that means I have 1.32 US dollars for every euro. Since I want to get rid of the euros and end up with US dollars, I am going to put the 1.32 up top and put 1 euro on the bottom. Okay, now in my calculator, I'm going to put 45 over 1 times 132 over 1. And when I multiply that out, I'm going to get 59.40, and that's US dollars. If I chose to use the other conversion factor, I would have multiplied, so let me section this off here. I would have multiplied by 1 US dollar on top, and I would have put 0.7576 euros on the bottom if I use this conversion factor. But when I multiplied that out, if I use this conversion factor, I would have ended up with the same answer. So it truly doesn't matter which one you use as long as you label it correctly. Okay, last example. It says a gas station in Canada sells gasoline for $1.34 per liter, and that's in Canadian dollars. Let's see, what is the price in dollars per gallon? So we have two things we need to change here. We need to change Canadian money into US dollars, and we need to change liters into gallons. So let's first change Canadian dollars into US dollars. So I'm going to write down 134 Canadian dollars, and this is per liter. So I'm going to put liter on the bottom. Per, remember, means division. If you look back at your notes for the key words, per means division, so I put liter downstairs. Now I'm going to use a conversion factor to change Canadian money into US dollars. So if I look up here, if I have 1.005 US dollars, that's equivalent to 1 Canadian dollar. So I have 1.005 US dollars is equal to 1 Canadian dollar. So if I look back now, I've gotten rid of my Canadian dollars and I'm left with US dollars. So now I still need to get rid of liters and change that to gallons. So what I'm going to do is I'm going to scroll back up and look for my conversion factor. Since we're going from liters to gallons, that's changing different systems. It's going from metric system to our US system. So I need to look at my conversion table that's crossing between systems. And I want to look for some kind of conversion factor that goes between gallons and liters. Here it is right here. So 1 gallon is equal to 3.785 liters. So that's the conversion factor we're going to use to change liters to gallons. So scroll back down. Since I want to get rid of the liters, and here's the trick, since liters is on the bottom, if I want to cancel it, the liters needs to go on the top now. Because most of everything we've done so far has been whatever you're trying to cancel out goes on the bottom. But really, whatever you want to cancel out, you just do the opposite. If it's downstairs, you want to put it upstairs, and if it's upstairs, you want to put it downstairs. So we're going to put liters on top, and we said when we look back at that conversion factor, it was 3.785 liters for every gallon. So now I've got it so I can cross off my liters. When I multiply all that out on my calculator, I'm going to put 1.34 over 1 times 1.005 over 1 times 3.785 over 1. I'm going to multiply that all together, and I'm going to get $5.10. That's what's left on the top is the dollars. And on the bottom, what's left is gallons. So I can say per gallon because that's downstairs. So that concludes our lesson for Introduction to Unix.